Hello, my name is Winroy, and I'm with Challenge 2016. I'm here in a series of videos where I'm going to show you different things involved with functions, and a whole bunch of other things involved with calculus. So today I'm going to talk to you about tangent, specifically the tangent function and the arctangent function, and showing you the domain, the range, and how it increases. And also I'm going to show you the inverse tangent as well, the arctangent as it's called sometimes. I'm going to show you its domain, its range, and whether or not the function is one-to-one. So now I'm going to show you first the tangent. So already right here, I've already drawn the tangent. I already drawn the tangent graph and a tangent graph when the domain is restricted. So here is the normal tangent graph. So we notice here with the normal tangent graph, we have a couple of these graphs right here, lines, are separated by asymptotes. Now, at these asymptotes, that's where our function is considered undefined, meaning that right here, here, our function would be 1 over 0, where that's not possible. We can't have anything over 0, or then it's undefined. So then our domain is going to be all real numbers except for those numbers, because those numbers will make our function undefined, meaning that it's not valid, it's not there, it's almost as if it doesn't exist. So then if we were to go ahead and do the range, our range would be all negative y values and all positive y values. So then in that case, our range would be, it would go negative infinitely up and negative infinitely down. So then, but thing is though, it's not one-to-one. As you notice here, when we make a horizontal line, there's y value here, and then also right here, there's an x value, but also right here, at that same y value, there's another x. And at this y value, there's another x. So then that means that it does not pass the horizontal line test. But let's say we were to go ahead and do what I've done over here on the left. Let's say we were to go ahead and restrict the domain. If the domain has been restricted though, restrict the domain so that it is only at pi and negative pi over 2 and at pi over 2. So we restrict the domain to be negative pi over 2 to pi over 2. Then now our function can be considered one-to-one. That's because if we're going to draw a horizontal line, there's only one x value. But then also our range wouldn't change either. So then that means our range would equal the same thing, as before. All negative y values and all positive y values. Now the way this increases that the normal tangent function would increase infinitely upward and infinitely downward. It would keep going down, 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 getting ever so closer to this number right here. Very, very close to this value over here. To these asymptotes. It would get really, really close, but it would never, ever, ever touch it. It would never reach it. It would never even get close. It won't even think about getting close, because at that point it'd be 0 and it'd be undefined, and we can't have that. So now I'm going to show you the inverse tangent function. So now the inverse tangent function, it looks something like this. So we really go ahead and write it. Our inverse tangent function, it looks similar to the arc tangent, or simply tangent to the negative one power. It would look a lot like this right here. Now, but when this is graphed though, when it's graphed, it would look like this. We got it set right there. When it's graphed, it would look a lot like this. You would have one right here, asymptote. Let's say it would be another one right here. Then we have another asymptote. There'll be another asymptote up there. Then we have an asymptote right here. Then we have another one. And we have another asymptote right here. Now, we have another asymptote over here, and then we have another line over here. Now, you may ask yourself, is this function one-to-one? Turns out, yes, it is. This function is in fact one-to-one. Now, the reason why this function is one-to-one is that when you go ahead and do a horizontal line right through it, you notice that there's only one x value for every y value. Now the reason why this function is considered one-to-one is that these lines, when you do the horizontal line test, for each of these sections, it does not pass through twice. It only passes through once. Because remember, as I said before, this line right here will ever so closely increase till it gets just about to this asymptote, but it'll never cross that asymptote, meaning that no matter where you draw the horizontal line, it will always be 1 to 1. But now let's go ahead and let's see what the domain is. Now our domain now will change. It'll almost swap identically with the range. So then our domain would change from would change from all real values to being all real, to being all positive and all negative x values. So our domain would then be negative infinity to positive infinity. So it would be all positive and negative x values. But now our range changes. Our range now will change from all real, not all real, but all negative and all positive y values to simply -1 to 1. The reason for that is that when you go ahead and restrict the domain of the range, you don't restrict the range. Well, yes, actually, when you do restrict the range. So if I go ahead and redraw this graph right here, when we restrict the range of this function, because it's the inverse. You would instead restrict the domain, restrict the range. Because normally the range would be very similar to our domain here. Because that's a mistake. That was a mistake on my part. Originally, our range would be very similar to here. That would be all real numbers. It'd be all real numbers, except for very specific y values, which could be pi over 2, 3 pi over 2, and 5 pi over 2. And these values can be plus or minus. Very similar to up in here. These values can also be plus or minus. So those could be plus or minus in the case, because it could be up, down, left or right. So I'll go ahead and graph this, but then graph it with the range restricted. It will look a lot like this. And I've restricted the range to be at pi over 2, or in this case, pi over the case. I'm going to restrict it so that it's easier on me and easier on you guys. I'm going to restrict it so that it's 1, -1 and +1. So then down here, this is -1 and this is +1. So then now our range would change to, instead of all the values, to be from -1 to 1. Now, the way this one increases is that it will always increase very slowly to this asymptote right here. This asymptote at +1 and the asymptote at -1. You'll get ever so closely, but it will never touch it, because then at that point you'll make the thing undefined. Very similar to the normal tangent function. And also you will notice that it will increase infinitely to the left and towards the right, but it will never reach that asymptote. I'd like to thank you for watching my video, and that sooner or later I will have another video posted again, maybe soon, maybe at some other point in time. But I really appreciate you watching my videos and helping me with trying to start a series, and it's really greatly appreciated. So thank you and goodbye.